There, I pressed it. So what is the difference between a sequence and a series? Because they go hand in hand. So don't forget what we learned now, because otherwise you'd be in big trouble. So here is a sequence. 1, 1/2, 1/3, 1/4, dot, dot, dot. This is a series. 1 plus 1/2 plus 1/3 plus 1/4 plus dot, dot, dot. Do you see the difference? A sequence is a function whose domain is the positive integers, right? A series is the sum of the terms of a sequence. So the kinds of problems we're going to be doing this chapter is I give you a series like this. Does it converge or does it diverge? In other words, if you add it up, like if you keep on adding these numbers forever, do you get a finite sum, like a number, like 2 or e or pi? Or does it diverge to infinity? What do you think? What's your feeling on this one? If I keep on adding these numbers forever, does it add up to a number? Now, every year there's always somebody that says 2. You know why that doesn't make sense? Because if you just add the first 4, it's bigger than 2 already. So if it did converge to a number, it would be a number bigger than 2. Huh. What number could that be, maybe? Anyway, today we're going to look at only 2 special kinds of series, arithmetic and geometric, right? We have formulas for those. So, but before we even do that, let's review sigma notation. You guys remember sigma notation from matrices? Okay, we better do a quick review. Sigma, this is the Greek letter sigma, capital sigma, and k equal 1 to 5 k squared. That's what a typical sigma notation would look like. So here is your formula. What numbers do I plug into this formula? What number do I start with? The number on the bottom, and then you just plug in consecutive integers until you hit the top number. So what you're going to do is plug in 1, 2, 3, 4, 5, and the sigma tells you to add it up, because sigma is the Greek letter for S, which stands for sum. So plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, and the sigma simply tells you to add them up. So that's why when we do series, we're going to be using sigma notation. So the 2 that we're going to talk about today, arithmetic. Now let's review. What is the explicit formula for an arithmetic sequence? Because we're actually going to use these formulas. A1, and you better know this for tomorrow, plus n minus 1d. But how do you find the sum of the first n terms in an arithmetic series? Well, I don't know what you guys covered. Did you guys learn this in Algebra 2? Because I know they do it in 2A and 2B, but do they do it in 2 honors? It doesn't matter, because I'll teach you like you don't know anything. Does this look familiar? N over 2 times A1 plus AN. That looks familiar? So what are you going to say? What? Okay, do you guys remember the story of Carl Gauss? Carl Gauss is one of them.
Now I remember this.
Yeah.
Who told you that? Mr. Cropsey? Mr. Rubash?
You.
I
read
did.
in a book about math history. There was like a little kid, and his teacher asked him, add the sum of the numbers like 1 through.
Hey, don't give away the secret. Anyway, the 3 greatest mathematicians of all time, who are they?
Gauss.
Carl Gauss,
Euler?
Sir Isaac Newton,
Leibniz, Cartesian.
Archimedes.
Not Rene Descartes.
Descartes. No, Descartes, he top 20 probably.
Not Euler?
Maybe top 50, I don't know. Anyway, when Carl Gauss was a kid, he went to school and the teacher got mad at the class and he said, you know what? I want everybody to add up the numbers from 1 to 100. 1 plus 2 plus 3, and of course these are like 7 and 8-year-old kids, right? So he figures they're gonna go, okay, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and then the bigger the numbers get, the longer they're gonna take, so it'll take them all morning, except Carl Gauss did it in 5 seconds. first with the last, you get 101. If you add the second with the second to the last, you get 101. If you add the third with the third to the last, you get 101. So every time you pair up the numbers like this, you get 101. So then you just have to figure out how many pairs you have. Well, if you have 100 numbers, how many pairs are there? 50. And every time you pair them up, you get 101. So shouldn't the answer just be 50 times 101? Which is 5050. Carl Gauss did that in 5 seconds. But that's where this formula came from, because look, isn't this an arithmetic series? There's a common difference. Keep adding 1 to get the next term. So anytime you have an arithmetic series, you can use the Gauss method. First term plus last term, so this plus this. And if you have n numbers, how many pairs do you have? N over 2. So that this formula makes perfect sense. Okay, so let's do a problem that you're going to see on your homework. Number 1. Find the sum of all the 3-digit positive multiples of 7. Okay, we'll do the same problem except we won't do multiples of 7. What do you want to do? The other class did multiples of 9.
11, 13.
No, I'm sorry, they did 11. You know what? 11 is good because then they actually learn something. Okay, so find the sum of all the 3-digit positive multiples of 11. So what's the first 3-digit number that's divisible by 11? 110. Very good. And then what's the next one? 121. Add another 132. And then you just keep on adding until you get to what's the largest 3-digit multiple of 11? The other class said 999. What? You know there's a test for divisibility by 11? You know that test? Oh, like, okay, for example, what the number 2, 3, 5, 7, give me a number. 8, 15, and 5. Is this number divisible by 11? How do you tell? Without actually dividing it by 11. Start with the first digit, add up every other one. What is 2 plus 5 plus 8? 15. Now starting with the second digit, add up every other digit. 3 plus 7 plus 5. 15. If you subtract those two numbers, and this number is divisible by 11, then the original number is divisible by 11. Is 0 divisible by 11? Yes, because when you divide by 11, you get 0 remainder, right? Yeah, so, is it 999? No, because when you add up this and this, 18 minus 9 is not divisible by 11. So what is it? 990, because 9 minus 9 is 0, which is divisible by 11. Anyway, come on, 11 goes into 99, right? All right, so add up these numbers. So we have a formula for that right here. This is the formula. So, if I want to add up these numbers, how do I know it's arithmetic? Because there's a common difference of 11. So, the formula is n over 2, except the problem is I don't know how many terms there are. I don't know how many numbers there are, but I do know what the first term and the last term are, so I can at least do that. All we have to do is figure out how many terms there are. Now, can we do that? Yes, we did it last chapter. In fact, it was on the quiz, right? How many 3-digit multiples of 11 are there, right? Except I think on the quiz you guys did 13, yeah? Okay, so how do we find that out? We use this formula. We use the sequence formula to figure out how many terms there are. So, what do I plug in for AN? 990. This is the nth term, except we just don't know what n is. Equals A1, 110, plus n minus 1, d. And what is d? 11. If I solve this equation for n, that'll tell me how many terms there are. So let's get busy. What do you want to do? What did you guys do on the quiz? I don't know, we got it wrong. I would subtract 110 first, and so you get 880 equal n minus 1 times 11. Next, I would divide by 11. 11 goes into this. What? 80 times, so therefore n equals. So there's 81 terms. This is the 81st first term, boom, there you go. There's your answer. And then can you compute that number for 1 point? I hope so. Alright, the other kind of series we're going to look at today is geometric. So this is arithmetic, because it has a common difference. What happens when you have a common ratio? Like this. 2 plus, no, you know what? Let's write out sigma notation here. K, now usually when you do sigma notation, the common letters we use are K, I, and J, and N. I just put whatever I feel like at the time. Okay, K equal 1 to 7, 2 times 3/5 to the N minus 1. Now, just by looking at this formula right here, how do I know it's geometric? Because from last chapter, right? Anytime you see a number to the nth power, that's geometric. And the number in the parentheses is the common ratio. Now, if you don't believe me, let's write out the first few terms. What happens when you plug in 1? 2. Plug in 2. 6 bit. Plug in 3.
18, 20.
Oh boy. What?
18 over 25.
18, 20. We can't even plug in 3. Okay, now, what do I need to multiply to get the next term? 3/5. See how it's the number in parentheses? If you know that, that can save a lot of time now. Okay, so anytime you see a sigma formula and you have a number to the nth power, that's geometric. And for those of you who haven't figured it out yet, geometric is the same thing as exponential, right? A number to the nth power, right? Now, how do I find now from 1 to 7, that means the sum of the first 7 terms. Now, I can actually write out the first 7 terms and add them up, or we have a formula. The sum of the first n terms of a geometric series is a1, 1 minus r to the n, all over 1 minus r. Does that sound familiar to you? It doesn't matter. You got to put this in your memory bank here. So yeah, if you want to write out the first 7 terms, add them up. But then what if it said 1 to 70? You really want to do that? No. So that's why we have a formula. It's good. So how do I find the sum of the first 7 terms? Well, it's going to be the first term, which is 2. 1 minus r. What is r in this problem? 3/5 to the 7th power, all over 1 minus 3/5. There you go. And then of course, can you compute that for 1 point? No, so Bryson Lee, just leave it alone there. Just stop right there. Okay, that's fine. But the main thing is you know how to plug in the numbers. Okay, but now, what would happen if we have the same problem except 2 times 3/5 to the n minus 1, except we're going to go from, hey, that's illegal notation. How did I use a k there and an n there? That's wrong. Nobody said anything, strike 1. N equal 1 to infinity. So what would happen if this thing just keeps on going forever? What happens if I add those numbers up?
Converges to 2 over 1.
Now the thing is, when you have an infinite series, either it's going to converge, which means it adds up to some finite number, or it's going to diverge. Now, what does diverge mean? Diverge means it doesn't converge. That's really the definition. Okay, but there's different ways a series can diverge. It could diverge to an infinite, it could be an infinite sum, or it could diverge to negative infinity, or it could just simply diverge. In other words, it doesn't go to anything. Remember Mean Girls? Okay, well, let's see. Well, luckily we have a formula for this. The sum of an infinite number of terms of a geometric series is simply, and this is one of the most beautiful formulas in all of mathematics. It's simply the first term over 1 minus r. Look how nice and simple that formula is. But you can only use this formula if the absolute value of r is less than 1. So you look at this sigma notation. Hey, this is an infinite geometric series. How do you know it's geometric? Because you have a number to the nth power. How do I know it's infinite? I see an infinity sign there. What's the common ratio? The number in the parentheses. Otherwise, like I say, if you're not gonna remember that, you're gonna have to write it out and look at it. Well, is the absolute value of 3/5 less than 1?
Yeah.
Yes, sir. So that means I can use this formula. So the sum of this series is equal to the first term, which is 2, all over 1 minus r, which is 3/5. Look how easy that is. So 2 over 2/5 is equal to 2 times 5/2, which is equal to 5. If you keep on adding these numbers forever, you will get exactly 5. Is that mind-boggling to you? How can you add up an infinite number of things and get something? Well, you guys have been actually doing it since elementary school, but you just never thought of it. Here, let me show you. When was the first time you learned that 0.3 repeating was equal to 1/3? When was the first time you learned that? Don't say yesterday.
Third grade.
Or I have yet to learn it. And just like the last test, the probability test. Remember the poly, the leaky, and the H3. Remember that problem? Didn't I say 66 2/3%? There were, I swear, there is at least 10 to 15 people didn't know that this was 2/3. They wrote just 66 2/3 over 100. What does that mean? That's 2/3. Anyway, it reminded me of this because this is 1/3. What?
I thought it was a typo when they did it.
66 2/3.
Because I thought they
Would it have been better if I wrote 66.6 and the repeating over the 6? That would have been better. That's the same thing as.
Yeah, I thought that's what you meant, and then you wrote the 2/3 also. So I did 2/3, but.
Oh my goodness.
I guess we're
Anyway,
close on that.
when was the first time you guys learned this?
Third grade. Third grade.
Okay. This is an infinite geometric series. You guys probably just never thought of it that way. Because look, what does that stand for? Doesn't that stand for 3/10? Because that's in the 10th place. What does this stand for? 3/100. What does that one stand for? 3,000. And so forth forever. Isn't this a geometric series? What's the common ratio? 1/10. Is the absolute value of 1/10 less than 1? Yep, so I can use the formula. So this is equal to the first term, 3/10 all over 1 minus r. So that's 3/10 over 9/10 multiply top and bottom by 10, and you get 3/9, which is equal to 1/3. So yeah, it was you're adding up an infinite number of things here. How come you guys understood it in 3rd grade? But now your mind is getting bent. I don't know. Anyway, so most of the problems on tonight's homework are dealing with infinite geometric series. So let's take a look at some classic problems. Okay, the first one is the bouncing ball problem. That would be number 6 on tonight's homework. So let's say you have a ball, and okay, I don't want to make it the same as that, so this is 8 meters. We're going to start at 12 feet. I'm going to drop a ball from 12 feet. Every time it hits the ground, it's going to rebound to a height that is 66 2/3% of the previous. Oh my. Okay, now everybody understands 66, and your elementary school teacher would be so disappointed. Who's that, Mr. Chun? I'm gonna tell next time I'm gonna see. You know, they don't even know 66 2/3% is 2/3. Anyway, every time it hits the ground, the ball is gonna rebound to a height that is 2/3 of the previous distance. So what is 2/3 of 12? 8. And then of course the ball is gonna come down. Then when it hits the ground, it's gonna rebound to a height that is 2/3 of this previous height. 16/3. Then it's gonna hit the ground, and then it's gonna rebound to a height that's 2/3 of this. 32/9, and it's just gonna keep on going forever. This is theoretical, of course, because in real life the ball is gonna stop bouncing, right? Because of friction and whatever. Okay, well, so this is just a theoretical problem. So, what is the distance that the ball traveled? This is called the bouncing ball problem. Every book has this problem. Well, in fact, we just went over this. You know that 5th grader that I work with? We just went over this. So he said, oh, Mr. Park, I would add up all the down arrows, add them up, then I would add up all the up arrows, and then add the 2. So that's what he did. I said, okay, that worked. So let's add up all the down arrows. What is that would be? What would that be? 12 plus 8 plus 16 thirds plus 32 ninths. And this thing keeps going forever. Hey, that's an infinite geometric series. What's the common ratio? What do I need to multiply?
2/3.
2/3. What a surprise, right? So how do you, and is the absolute value of 2/3 less than 1? Yeah, so we can use the formula. The sum of an infinite geometric series is the first term over 1 minus r. And I think we can do that one in our head, right? 36, right? Because 1 minus 2/3 is 1/3. Dividing by 1/3 is like multiplying by 3, right? Okay, now let's add up all the up arrows. So 8, 16 thirds, 32 ninths, forever. Hey, that's an infinite geometric series. First term, all over 1 minus r. That's 24. And so if I add these numbers, you get 60. So that's the distance traveled by the ball. But see, just like lots of infinite series, you can group them in different ways. So the way I would do this problem is, I am gonna group like these two, and then those two, and those two. Okay, and you'd still get an infinite geometric series. What would the first term be if I group them like that? 12 plus 8 is 20 over 1 minus r. And what does that come out to? Really? Come on, dividing by 1/3 is like multiplying by 3. It's 60, I get the answer already. I just grouped it in a different way. And you can do that when you have infinite series. Well, you can even regular series, you can group them with whatever ways you want. Anyway, so this is the bouncing ball problem. I'm pretty sure you're gonna see this on the first quiz with the numbers changed. Okay, another one, probability. I forgot to do this on the period 1, but that's okay because now it's gonna be on the video. Remember the one where Bert and Ernie take turns drawing marbles? We still gotta know probability. Okay, here, let's do a problem. How many, okay, so in the bag, in a jar, how many red marble? 3 red and 1 black marble. So Bert and Ernie take turns. Okay, let's say Bert goes first. Bert and Ernie take turns drawing a marble. So remember you guys did, what's the probability that Bert would win? Okay, but now, let's do it with replacement. So in other words, you're gonna take a look at the marble and then put it in. Put it back in and do it again, right? So, what's one way Bert could win? Couldn't he pull out the black marble on the first draw? What's the probability of that happening? 1/4. Now, another way Bert could win is Bert could go first, Ernie would go second, but they would get red, and then the black comes out. Why don't we just write red, black? Okay, what's the probability of pulling out a red marble? 3/4. Put it back in the jar. What's the probability of pulling out another red? 3/4. Put it back in the jar. What's the probability of pulling out a black?
1/4.
There you go. Is there another way Bert could have won? Yeah, red, and then the black comes out on the 5th one. Okay, what's the probability of pulling out a red marble? 3/4. Put it back in the jar. 3/4. Put it back in the jar. Put it back in the jar. And then 1/4. Yeah, but Mr. Park, wouldn't this thing go on forever? You bet your bippy it would. Okay, so can I add up these numbers? Yes, it's an infinite geometric series. And what is the common ratio here? What do I need to multiply by?
9/16.
9/16. Is the absolute value of that less than 1? Okay, we can use the formula then. So, first term, here, let's just do it over here. First term, 1/4, all over 1 minus r. Do we dare simplify this? Multiply top and bottom by 16. So you get 4 over 16 minus 9, which is 4/7. Another classic example. Probability with replacement. Thing goes on forever. Okay, another example that you will see in tonight's homework. Okay, so tonight you have an equilateral triangle. Let's do a square. The other class had trouble with the square. Okay, let's let's start with the square of side, give me a number.
4.
Okay, that's a good number. Because other class used 3 and then they ran into problems. Okay, so we start with a square like this. Connect the midpoints of each side to form another square. Connect the midpoints of that square and you get a smaller square. Connect the midpoints of that one and you get another square, and you keep on doing this ad infinitum. Who takes Latin? Matsuzaki sounds like he would take Latin. What does ad infinitum mean? Ad infinitum. To infinity and beyond, right?
No.
No, just to infinity. Alright, what is the sum of the areas of all the squares here? Tonight you got an equilateral triangle. Well, what's the area of the first square? 4 by 4. 16. Okay, now the next square. What's the area of this next square? Now you gotta actually use geometry. Well, if this is 4, wouldn't this be 2? 2 and 2? What kind of triangle is this right here? It's a 45, 45, 90. So how do you get the hypotenuse? You multiply the leg by root 2, so you get 2 root 2. So square that, and you get 8. Ooh. Okay, next square would be this one here. How do I find the area of this next square? Well, if this is 2 root 2, then what? What? Then what's half of it? Root 2. So this is root 2. This is root 2. So again, you got a 45, 45, 90 triangle. So that would be 2. So squared, you get 4. And you just keep on doing this for, hey, it's an infinite geometric series again. What a surprise. And what's the common ratio?
1/2.
Well, of course, the absolute value of that is less than 1. So, first term, all over 1 minus r, 32. That's the sum of all the squares. Another classic problem. Now, do not do this. And if anybody does this on the next quiz, which I probably will give a problem like this. 1 minus 2 plus 4 minus 8 plus 16 minus 32 plus dot dot dot. So the people that don't pay attention, they just memorize the formula right before the quiz and they go, oh, this is an infinite geometric series. What's the common ratio? What do I need to multiply to get the next term? -2, right? So they just go, oh, I remember the formula. First term over 1 minus r. Oh, 1/3. If I keep on adding these numbers forever, you will get 1/3. No, that don't make sense. Or even if I made it all plus. What if I made it plus? 1 plus 2. Maybe this one would make. If I keep on adding these numbers forever, you get first term over 1 minus r, so -1. I add up an infinite number of positive numbers, you get -1 as the answer. I don't think so. So what happens when the absolute value of r is not less than 1? The series diverges. So like this one diverges, we say it diverges to infinity. This one simply diverges. Because look, you're adding a positive number, then a bigger negative number to it. And you're adding a bigger positive number, a bigger negative, so it just kind of jumps back and forth like this. So it simply diverges, whereas this one would diverge to infinity. Okay, next thing, interval of convergence. Super important in calculus. So what if I give you a series like this, sigma, k equal 1 to infinity, 2x minus 3 to the k minus 1. How do I know this is a geometric series? Because you have something to the k. Now, if you don't know, like I said, write out the first few terms. Okay, let's write out the first few terms. Plug in 1, 2, 3, 4. What happens when I plug in 1 for k? You get 1, right? 2x minus 3 to the 0 is 1. Okay, plug in 2. You get 2x minus 3. Okay, plug in 3. 2x, no, just go 2x minus 3 squared. Because when you're trying to show off, then you're going to do the cube one for me too then. 2x minus 3 cubed plus dot dot dot. Now see, the way I wrote it on tonight's homework, I just wrote it like this, but come on. By the time we get to the quiz, I'm gonna give you sigma notation, and then you write it like this. Anyway, now can you see it's geometric? What do I need to multiply to get the next term? What is R? 2x minus 3. Now, what does the interval of convergence mean? It means, what numbers can I plug in for x right here so that this series will converge? Okay, well, what do we know? In order for a geometric series to converge, what has to happen? The absolute value of R, which is this, has to be less than 1. Otherwise, it diverges. So, if you solve for x in this inequality, that will tell you the interval of convergence. Now, do we know how to solve inequalities? No, we got easy ones. This would be like an easy one, but believe me, there's going to be tougher ones. Now, when do we cover inequalities? First or second quarter, yeah? Hopefully you didn't purge everything. So for this kind of inequality, what's the best way to solve it? Put 2x minus 3 in the middle. Now what do I put here and here? Negative 1 and 1. This is the kind you get on the SAT and ACT, the easy kind. How do I solve for x? Well, first of all, how do I get rid of a minus 3? Add 3 across the board. So 2 is less than 2x is less than 4. How do I get rid of that 2? Divide by 2 across the board, so you get 1 is less than x is less than 2. This is called your interval of convergence. That means if x is any number between 1 and 2, like for example, 1 and a half, if I plug in 3 halves for x, that series will converge. Any number between 1 and 2. How about square root of 3? Yeah, that would converge. And then the last one, I just want to inform you about problems 8 and you see the one that says quiz? That used to be a quiz, and you would have to look it up on the internet, or you had to figure it out on your own. But we'll just call it number 9 now. The Coke snowflake. First of all, number 8, I just want to show you this because I don't want you to give up on it. This is the kind of problem where if you want to be good at math, you sit down and you work it out. Okay, so sigma, what does it say? N equal 1 to infinity, n over 2 to the n. Okay, I'm going to tell you right now, this problem is on the quiz. I'm just going to change the 2 to a 3. But now that I told you 3, change it to a 4. Now that I told you 4, I'm going to change it to a 5. Well, anyway, it's going to be a different number than 2, okay? Okay, let's write out the first few terms. Plug in 1. 1 half. Plug in 2. 2 fourths. Plug in 3. 3 eighths. Plug in 4. 4 sixteenths. Plug in 5. 5 32ths. And so forth. Is this a geometric series?
No.
Do I keep multiplying by a number to get the next one?
No.
No, this is not. So how come it's on the homework, Mr. Park? Because you can massage it into geometric series. That's all the hint I'm going to give you. You got to massage it. And then when you see it, don't look at the written solutions that I gave you or the video now. Because it's so neat, I guarantee it's going to bring tears to your eyes. If you don't get emotional by doing this problem, you're not human. It's so neat. And then the Coke snowflake. Let's talk about this because there's going to be a problem on the quiz or test, or maybe both even. So like we were watching on the video, I thought we were going to be able to watch the end of the video today, but we're not. We don't have time. We need about 20 more minutes. Okay, you guys remember the Coke snowflake or the Coke curve? You start with an equilateral triangle of side S, right? And then what do? Well, first of all, how many segments do you see here? Because that's important, the number of segments. There's 3 segments, right? Remove the middle third of each segment and replace it with another equilateral triangle. So that's what it looks like after one iteration. Now how many segments are there? This is important to doing the problem now. Look, 1, 2, 3, 4 times 3, right? 12. So for each of the 12 segments, remove the middle third of each segment and replace it with another smaller equilateral triangle. that are there now? There's a pattern.
48.
What?
48.
Okay, I heard two different answers. 24 or 48?
48.
Yes, 48. So on each of those 48, you remove the middle third and replace it with a smaller equilateral triangle. I'm not going to go all the way around. And you keep on doing this forever. Now the thing that's neat about the Koch snowflake, the reason why people study it so much, it's a fractal that has a finite area, but an infinite perimeter. That's what's so neat about it. And you're actually gonna have to show it. Show that the perimeter is infinite and the area is a finite number. You're gonna have to tell me what that number is. Of course you can look it up on the internet, but you're gonna have to be able to do it on your own because of course I'm gonna change it. I'm not gonna give you the exact same problem. I'll probably give you the Koch square like I did last year, and you know what happened then, right? All hell broke loose. Start off with a square. Remove the middle third of each segment and replace it with another square. And you just keep doing this forever. What is the final area? So first you gotta learn how to find the area of the Koch snowflake. Okay, so let's start with this one. If we have a triangle of side S, I'm just gonna start you on this now. What is the area of this triangle?
That's root 3 over 4.
Okay, root 3 over 4 S squared. And for those of you who still refuse to memorize this formula, you're just gonna chew up a whole bunch of time. It helps you on SAT, ACT, in any math class, especially in calculus. There's a lot of equilateral triangles in calculus. Okay, in the next iteration, it looked like this. Oh gosh. I'm not a good artist, so I just gotta do it from scratch. There. Because the people on the video, they're just drawing it like, Okay, now, I started with this. Now, what did I have to add to get this iteration? How many equilateral triangles did I have to add to this to get that picture?
3.
I had to add 3 smaller equilateral triangles, right? So I have to add 3 equilateral triangles, root 3 over 4 times the side squared. Well, what is the side of each of these triangles, these smaller ones? I think they even said it in the video. Or just look at it. It's S over 3, correct? Isn't it 1/3 of the side? Because that's what you removed, the middle third. Everybody see that? Okay, now the next picture. Oh gosh. Can I just leave the lines in? Maybe I should have somebody come up and try. Can somebody come up and try? Who's a good artist? Okay, there. Oh, forget that. Okay, now I added smaller equilateral triangles to this one. How many? Okay, so I'm going to add, how many smaller equilateral triangles did I just add? No, you guys just told it to me back here.
12.
48.
12.
Oh no, that's a 12.
12. So I'm adding 12. No, count them if you have to. 1, 2, 3, 4, just on this side. But then you got 3 sides, so 4 times 3, 12, right? 12 smaller equilateral triangles, so root 3 over 4 times the side squared, except what is the side now?
That's over 9.
It's going to be 1/3 of the previous one, right? So, S over 9. And there's a pattern here, people, there's a pattern. And then in the next iteration, I'm not going to draw it because I might hurt myself. How many of these smaller ones do I have to add? What's the pattern here? 3, 12. You guys told me the answer. 48. There's 48 smaller equilateral triangles. Root 3 over 4 times the side squared. And what would be the side? S over 27. That's right. And it goes forever. So to answer the question of what is the area of the Koch snowflake, you have to compute this. Now, is this a geometric series? And the answer is no, it's not. But it is if you take away the first term. See, this is like the secret of the Koch snowflake. Starting from the second term, it's geometric. Okay, so I'm not gonna do this for you, so I'm just giving you the secrets right here. So anytime you do a Coke curve, see, if you don't remember this stuff, you're just gonna be lost. So like if I give you the Coke square or whatever I give you, you gotta know what's happening. All that's changing are the numbers. Everything else stays the same. Okay, so starting from the second term, it's geometric. So you have to figure out what the common ratio is, right? I'm not gonna tell you, but, and then once you get the answer for this, then don't forget to add this, and then that's your answer. Of course, you can look it up on the internet, but I'm not gonna help you that much. I told you all the secrets already. Starting from the second term, it's geometric. And anyway, so you know that kid I'm working with, I gave him that problem as the homework, the Coke square. Because we actually did this in the lesson. So the Coke square, he has to, because there's something really neat about the Coke square too. I'm not gonna tell you because you guys might see it on the quiz. Okay, questions?
So is it true that like for every Coke shape, the second term and after?
Yes, that's the secret. Starting from the second term, it's geometric. Because I remember, I used to just give it as a quiz, see, quiz. I just give it on the quiz, and then they had to figure it out on their own. And they just go on the internet, and then some people just memorize stuff, and they don't even know what they're talking about. So like some people got 0 on that quiz, I remember. 0 out of 20. But now it's just part of the assignment. Because then I got bigger and better problems to give you. All right, we are done then. So we have our test tomorrow, and we'll continue series when is the next time? Is tomorrow Friday already? Wow. Do I see you Monday?
No.
No. Huh?
Tuesday.
All right, so now the interesting stuff is gonna come. So Mr. Park, what happens if we have an infinite series and it's not arithmetic or geometric? That's where the fun begins. Oh, Oh, we no longer do that. We no longer do that in PCH. We used to do that up until maybe 15 years ago, I would say.
You have to use the definition.
Yeah, the definition.
Oh, okay.
Did you see the definition?
At the top,
Yeah. But we no longer do that. You don't need to worry about that. Well, at least somebody noticed something about that.